Although there are many alternatives to deploy a single-page application, you might find a situation where you need to deploy it in an isolated environment or just portability concern. So in this video, we'll be using SvelteKit to generate a single-page application and serve it in a single binary file with Go. We also cover how to deal with the basic behavior of single-page application not found route with the Go HTTP standard library, a practical use case to embed and serve the application with Go external libraries such as Echo and Fiber. The last one will be containerizing the application with Docker multi-stage build for a smaller image. So before we get started, please make sure that your computer already has Node.js, Golang, and Docker. Inside the root of the project directory, let's scaffold a new SvelteKit project by heading over to the terminal and then type npm init svelte add next. The directory name will be frontend. For the sake of simplicity, we'll be using skeleton project template with node type checking and then default configuration. SvelteKit has many adapters for building the application, but in this case, we'll be using the adapter static. So under the package.json file, replace the adapter from auto to static. At the svelteconfig.js file, replace the adapter from auto to static as well, and then specify a fallback with index.html for a pure single-page application mode. Back to the terminal and install the dependencies by running npm install. You'll notice that our terminal is not at the directory root where the package.json file is located. So we can navigate to the frontend directory by running cd frontend, or by just using -- prefix period / frontend and then press return or enter. Okay, the installation is completed. At the source route directory, open the index.svelte file. Add a svelte head and insert a title tag with the homepage as the content. Add a style tag and set heading 1 with the color of blue violet. Next, add a new file called about.svelte to create a route of the about page. Add a svelte head and insert a title tag with about. Add heading 1 with about and paragraph with this is the about page. Add a style for heading 1 with the color of green. Let's add an example to fetching the JSON data from the server, and we'll create the endpoint with Golang later in this video. Within a script, declare const of status and then use fetch with an argument of /hello.json for the endpoint. Add a method of then to resolve the promise with r as the object and then return it as JSON. Add a catch as a fallback with error as the object and then throw new error with error as the argument. Now create a p tag with the content of server response, and then use this svelte await block to handle the asynchronous data. Await status, loading, then data.message. Catch error, failed to load data. Now let's create a global style sheet at the source directory and name it global.css. Set the body selector with the background color of Alice Blue. Set a property of font family and the system font as the value. Next, add a new file called __layout.svelte so each element inside this file will be visible on all pages. Add a script tag and import the global style sheet. Add a navigation tag. Add an anchor tag with an href of / and home. Add another anchor tag with an href of / about and about. Add one more anchor tag with an href of /404 and 404. This link will be an example to navigate to the 404 page. The last one will be adding a slot to render all page components. Next, add a custom error page with __error.svelte. Add a script within the context module to run scripts before all components are rendered. Use export function load with the parameter of status and error and then return the object within the props of status and error. Now we can use this object within the script, export let status and error. Add a svelte head and a title tag of status within the curly brace. Add heading 1 with status and a paragraph with error.message. Add some style for heading 1 with the color of crimson. Okay, our simple application is ready. Now we can build the application by running npm run build prefix frontend. Preview the application by running npm run preview. Open the browser and navigate to the localhost port 3000. Okay, we have the homepage, the about page, which is failed to load the JSON data because we haven't created the endpoint yet, and the 404 page. As you can see, the run build command has generated static files inside the build directory, which we will serve with Golang. To start a Go program, we need to initialize it with go mode init and then the module path. The module path name is Go Embed Spa, which stands for single page application. You can also make it public with the github.com/your username and the repo name. Create a new file inside the root of the project directory called main with an extension of Go. Set the package name with main, add an entry point with a function of main. Just for a quick note, we'll be serving the application by using the file system first, so we can see the difference between before and after we embedding the application into the binary. Use the HTTP library with the method of handleFunc. If we hover over the function, you can see that this function has two parameters. The first parameter will be the route pattern, a slash for the root path. The second parameter will be a callback function with an argument of HTTP response writer and a pointer to the HTTP request. Let's move this callback into a function called handleSpa. Use the file path library with the method of join to join the front end and the build directory into a cross-platform file path. Hold the return value within a variable. Let's name this variable the build path. Now we can serve the directory with the HTTP library and a method of file server. Add an argument with HTTP and a method of dir. Use the build path as the argument. Add a method with serve HTTP, add a writer and request as the argument. If you remember, we need to add another endpoint to serve the JSON data. Add another HTTP handleFunc with a pattern of /hello.json and a callback function of handleHello. Now create the function of handleHello with a parameter of HTTP response writer and a pointer to the HTTP request. Create a variable with res and error. Use the JSON library with the method of Marshall. Add a map with a key type of string between square bracket and a value with type of string. Now we can use the JSON string with a key of message and a value of hello from the server. Just to be safe, if the error isn't nil, throw the HTTP error with writer, error string, and a HTTP constant for status bad request and then return. Now we can write this JSON data with writer.write and then res as the argument. Set the writer with the header method and set the content type with application/JSON. Okay, we have covered the JSON endpoint. Now head back to the main function and create a server by using the HTTP library and a method of listen and serve. Add a string of port 5050 as the first argument and a callback function with nil. Let's print a message to the console using log library and a function of println or printline. Add an argument with a string. Let's say the server is listening to port 5050. We also need to wrap the server function with log.fatal so there will be a message if the server failed to start. Head back to the terminal and start the application by running go run main.go. Okay, we have log message to indicate that the server is up and running. Now open the browser and navigate to localhost port 5050. Try the navigation, looks good, and the fetching JSON data also looks good. Now let's try to access the 404 page. As you can see, we've got an error of 404 not found from the server side. The problem occurs because the routing logic is handled from the client side, which is the index.html. This is the basic behavior of single-page application. We can solve this problem from the server side with a conditional by forwarding the not found route to the index.html. So inside the handleSpa function, use the OS library with the method of getWD. This function returns a rooted path name corresponding to the current directory, and this function doesn't have any parameter with true return value. So we will hold the value within a variable of root path and error. Add a conditional if error isn't nil, throw a new error with http.error. Add the argument with writer, error string, and an integer of HTTP status code. Let's use the HTTP constant for status bad request, and then return. Add another variable to reflect the absolute path of the project directory. Let's say path, filepath.join with an argument of root path, build path, and request.url.path. Validate if the file exists with OS library and a method of stat and use the path variable as the argument. Hold return value within a variable. The first one will be using underscores because we are not going to use the value and just the error. Use the if statement for OS is not exist and use the error variable as the argument. So if the file does not exist, serve the static file with another HTTP library and a method of serve file. The argument will be writer, request, and filepath.join for build path to the index.html file, and then return. And else, if error isn't nil, throw an error with HTTP error, writer, error string, and HTTP internal server error, and then return. So for the quick recap, we compare the requested path with the file inside the build directory. And if the file does not exist, which will throw a not found route, tell the server to serve the index.html file. Otherwise, just serve the build directory. Okay, head back to the terminal, cancel the operation by using Ctrl+C. Now let's use go build main.go command to compile our Golang code into the main binary. So now we can run the application from the binary by typing /main. Navigate to the localhost port 5050 in the browser, check the navigation, looks good. Direct access to the about page also looks good. Direct access to the unknown route, it returned a 404 page from the client side. So this is a quick and dirty way to solve the 404 page not found. Even though we run the application from the binary, our application is not a single binary file because it depends on the build directory. Try to delete the build directory, reload the application, and of course, it will give an error page because there is nothing to serve. So now is the perfect time to use the Go Embed feature to embed the build directory into the binary. First, create a variable with the keyword of var and then name the variable with buildfs and set type of embed.fs. Use the Go Embed directive to specify which files or directories to be embedded. In this case, will be frontend/build. Let's comment on the logic inside the handlespa function. We're going to write the code from scratch and just copy the build path variable. Because we want to serve the rooted directory from the embedded files, we need to use the fs library with the method of sub. And the argument will be buildfs and the build path. Hold the return value within a variable, let's say static fs and error. If error is a nil, throw an error with HTTP error, writer, error string, and HTTP internal server error, and then return. So now our embedded files have root directory, which is the frontend/build. Serve the files with HTTP library and a method of file server. The parameter will be http.fs with static fs as the argument. Add another method with serve HTTP with writer and request as the argument. Rebuild the static files and the binary with npm run build prefix frontend & go build main.go. Rerun the application, navigate to the browser and reload the page. Okay, it's a blank page. To be honest, for me, it took many hours to figure out how to solve this problem, so hopefully this can save your time. Now open the DevTool and see what caused the problem. As you can see, the star and the index.js are not loaded. The truth is not even embedded into the binary. If you read the official documentation, all files that begin with a period or underscores will be excluded, unless explicitly using the asterisk sign. And I think this is also applies to the directories as well. So let's open the build directory and locate all files starting with a non-alpha characters. The first one is _app, which is the reason why the star and the index.js are not embedded. So let's add asterisk sign after the build directory. The second one is after the _app pages. As you can see, there are some files with non-alpha character at the first letter. So we can add another go embed directive with frontend/build/apps/pages/asterisk. The last one is after the _app, assets, and pages. Save it, rebuild the binary, and rerun the application. Okay, now that we have successfully embedded the build directory into the binary. As in the previous section, we still need to solve the not found routes by using the same method. First, let's compare the requested path with the existence of a file inside the embedded directory with a variable of path and error. Use the buildfs and a method of open to access the embedded directory and set the argument with filepath.join to join the path of buildpath and the request.url.path. Now we can use if OS is not exist with error as the argument. Add an index and error variable to hold the value of buildfs and a method of readFile. Add the argument with filepath.join to join the build path and the index.html file. If an error is a nil, throw an error with HTTP error, use writer, error string, and HTTP status bed request, return. Add a writer.write and then set the index as the argument. Close the operation with return. Add else if an error is a nil, throw an HTTP error. Let's copy it from the HTTP status bed request. Optionally, we can add a writer with the method of write header and set the HTTP status accepted to force the header with status code of 202. The next step is to close the open embedded files with defer path.close to prevent the memory leak. Save it, rebuild the application, run the binary, open localhost port 5050, check the navigations, looks good. Direct access to the about page also looks good. Now try to delete the build directory. Reload the application. Alright, we have successfully embedded and served the single page application into a single binary file. The next thing that I want to show you is what happens if we move the Go entry point into another directory. Let's say cmd and then http. As you can see, there is an error warning from VS Code because the directory structure has been changed. Unfortunately, the embed directive does not support the directory pattern started with // which is a common pattern if we want to import library outside the parent directory. But luckily, we can export the variable. So under the frontend directory, create a new file called frontend.go. Set the package name with the frontend, copy the embed variable and paste it into the frontend.go file. Okay, we need to rebuild the static files first to remove the error warning. npm run build prefix frontend. Now update the embed directive because now it started with build directory and change it into one line per directory, so it will be more easy to read. Change the first letter with capital to make the embed variable exportable and create another function that can be exportable as well. Let's say func build httpfs with http.filesystem as a type for the return value. Create a variable with build and error to hold the value of fs.sub. Set the build.fs variable and a string build as the argument. If error is a nil, log.fatal to print out the error message. And then return the httpfs with build variable as the argument. Go back to the main function and update the build path variable with a string of build. Now we can import the embed variable with frontend.buildfs and replace all the buildfs variable with frontend.buildfs. Remove the fs.sub code because already created in the frontend package. Replace the http.fs with the frontend.buildHTTPFS. Rebuild the application, but this time we need to run the command with go build /cmd/http, which will generate a binary file called http. Let's run the binary /http. Reload the application. Reload the about page. Okay, everything works as expected. Along the way, our applications are getting more complex, or for whatever reason, we need to switch to another Go HTTP framework to make our life easier. The first framework that we're going to try is Echo. Echo is a high-performance, extensible, minimalist Go web framework. So let's start by creating a new directory inside the cmd folder called Echo. Add a new file called main.go. Set the package name with main at an entry point with the function of main. Since Echo is an external library, we need to import it manually by running go get and then the package name. github.com/labstack/echo/version4. So within the main function, declare a variable of app to hold the value of echo and the method of new. Now we can add log.fatal to wrap the server with app.star and set the port with a string of colon 5050. Serve the embedded directory within the app and the method of use and use the middleware.static with config. Set the config with middleware.static config, so if we hover over the static config, we will see all the available configurations. So the first one will be set the file system with the value of frontend.build_httpfs. The next one is to set the HTML5 to be true. If we take a look at the description again, it's almost similar to what we are doing previously by forwarding the not found route to the index.html. If you remember, we have another route called /hello.json. So create a function called handleHello, and because we are using the echo framework, the argument will be C to hold the value of echo.context and set the error as the return value. Now we can return the context with the JSON method. The first parameter will be an integer of HTTP status code. Let's use HTTP status OK. The second parameter will be an interface of the JSON object. So we can use the echo.map interface, set the JSON key with a message and a value with hello from the echo server. Now we can create a new route with the app and the method of get. The first parameter will be the route pattern, which is /hello.json, and use the handleHello as the callback function. Make sure the JSON routes code is about the static handler. Open the terminal and run the go mode tidy to fix the dependencies. Time to build the binary with go build /cmd/echo. Run the application within the binary. Open localhost port 5050 in the browser. Check the navigation. Direct access to the about page. As you can see, the server responds with hello from the echo server. Let's use another Go web framework called Fiber. Fiber is a bit different from other Go web framework because it's based on fast HTTP and not the Go built-in HTTP library. They claim to be the fastest Go HTTP framework and easy to use, so it's worth trying. Create a new directory inside the CMD folder called Fiber and then add the main.go file. Set the package name with main. Add an entry point with the function of main. Since Fiber is an external library, we need to import it manually by running go get github.com/gofiber/fiber/version2. Create a variable with app to hold the value of Fiber with the method of new. Use log.fettle to wrap the app with the method of listen and set the port with a string of :5050. Next, let's serve the embedded directory with the app and the method of use. The first argument will be the root pattern, which is a slash. The second parameter will be using the Fiber file system middleware and then the method of new. Set the argument with filesystem.config and set the root with frontend.build_httpfs. Just like we did previously, we need to handle the not found route with the not found file and set the value with index.html. Next, add a JSON route with app.get. Use /hello.json as a route pattern and handleHello as the callback function. Now let's create a function of handleHello, add a parameter with C and a pointer to fiber.ctx. Set the return value with error. Now let's return the context with c.json and then use fiber.map. Add a key string of message and a value with hello from the Fiber server. Head back to the terminal and run go mode tidy to fix the dependencies. Run go build /cmd/fiber to build the binary. Run the application from the Fiber binary. Navigate to the browser and open localhost port 5050. Awesome! Our application is shipped with zero memory allocation and performance in mind. Time for the Docker part to streamline the build process. Create a Docker file inside the root of the project directory and add Docker syntax with hash syntax equal docker/dockerfile:1.2. If you follow along with the video, we need to build the static files with Node.js and the binary with Go. So let's divide the build process into 3 stages. The first stage will be building the static files. The second stage will be building the binary. And the third stage will be the final stage to run the application. Let's start with the first stage. Add a from instruction to pull the node image and a tag of 16.15.1 -alpine3.15 and set the alias with frontend-builder. Add a workdir instruction with /frontend. Use the copy instruction to copy package.json and package.log.json to the front-end directory. Use the run instruction with npm ci to install packages and dependencies. Use the copy instruction to copy the entire front-end folder to the workdir directory. And then use another run instruction to build the static files with npm run build. Okay, that's all for the first stage. Now let's continue to the next stage. Use the from instruction to pull the Golang image with a tag of 1.18.3-alpine 3.15 and set the alias with binary builder. Since we are using the alpine tag, we need to install git manually by using the run instruction and then apk update, upgrade, update again, add git. Set the workdir directory with /builder. Copy the go mode and the go sum to the workdir directory. Use the run instruction with go mode download to download packages and dependencies. Use the copy instruction to copy the entire folder to the workdir directory. Next, we need to add the static files that are generated from the first stage. So we can copy the build directory from the first stage with copy instruction. Use the tag of --from equal frontend-builder and then copy the frontend build to the frontend build. Now we can build the binary with run instruction go build and then / for a new line, double space, and then use -o to set the binary name, let's say engine, from an entry point of cmd http main.go. Since we have 3 entry points, we can use the arg instruction to set custom argument. Let's say app name and set the default value with http. Now we can update http directory with the $sign and the app name. To reduce the build process of the binary, we can specify cgo enable to be 0, go OS with Linux, go architecture with EMD64. To reduce the size of the binary, we can set the LD flags with -w, -s, -extended LD flags with static -a. These build options will disable the table symbol, dwarf generation, etc. You can get more information about it by running go build help and go tool link. Okay, I think that's all for the second stage. Now for the final stage will be the image for running the binary. Add a from instruction to pull the distroless image, gcr.io/distroless/static. This image is maintained by Google, which is smaller than the Alpine image and has all the necessary features to run the binary. Set the workdir with app, copy the binary from the binary builder. Set the owner and group with a non-root user with chown. Expose port 5050 to make the service accessible outside the Docker network and set the entry point with /engine. Additionally, we can set the port to be configurable with env instructions. Set env name with app port and set the default port to be 5050. Now we can set the port with app port variable. Since our ports are dynamic and configurable, we need to update our Golang code. We can use the sprintf function and a string of %s, use the OS library and a method of getEnv to get the system environment variable of the app port. We can also update the println function with printf and set the port with OS getEnv for the app port. Let's update all ports for the rest of the entry points. Okay, now let's add the docker ignore file to exclude unnecessary files. And then add .git because this directories is only for versioning, .SvelteKit, node modules, and build because this directory will be generated inside the Docker build process. The last one is docker ignore and dockerfile. To build the Docker image, we can run the command with docker buildkit = 1 to enable the build kit and then docker build. Add -t to specify the image name, let's say spa. Set the tag name with colon, let's say http. Add a period to specify the Docker file path. And then press return or enter. The build process can take some time depending on the complexity and the internet speed. Run Docker image. Okay, we have successfully created the Docker image for the Go HTTP standard library. Before we create or run another Docker image, let's use Makefile to shorten the command. Create a new file inside the root of the project directory called Makefile. Add a variable with frontend dir with frontend, build dir with build, app name with HTTP, and app port with 5050. Define some commands for clean, static, build, and run. Just to be safe, let's add pony to explicitly tell the make they are not associated with files with clean, run, and build. For the clean command, let's add cd to the directory variable with a $sign and a frontend dir between opening and closing parentheses. Add a semicolon to close the command and add the backslash for a new line. Add an if statement for the existence of the directory with -d and the build dir variable semicolon. Remove the build directory with rm-rf and then close the if statement with fi. For the static command, let's add the clean command first before building the static assets. Cd frontend semicolon backslash, npm install, and npm run build. For the build command, let's use the docker build kit =1 docker build -t spa semicolon and then set the tag name with app name variable. Add the build arc with app name and a variable of app name, add a period for the Docker file path. For the run command, let's add docker run -d for detached mode or running in the background, -p and then app port variable for mapping the port between the host and the Docker, --name to define the container name with spa-app name variable. Set the environment variable with -e and then the app port variable. Use the restore policy with always to make the application run even after the Docker engine has been restarted. The last one will be setting the Docker image with spa and adding a tag variable of app name. Okay, time to build another image with make build app name =echo. Let's wait until the build process is completed. Okay, time to build a fiber image with make build app name =fiber. Run Docker images. As you can see, our application is pretty small for a single page application combined with the HTTP server. Try to run the image with make run. Succeed. Run the echo image with make run app name =echo, app port 5051. Run the fiber image with make run app name =fiber, app port 5052. Run Docker ps to list the running containers by default. All Docker images are successfully running. Navigate to the browser and open localhost port 5050 in the browser. Check the navigations. Looks good. Localhost port 5051. We have a response that this application is running from the Echo server. Localhost port 5052. Congratulations! Now that we have successfully run the single page application in a single binary file and then containerizing it with Docker multi-stage build for smaller image. Okay, I think that's all for now. If you have any question or suggestion, please leave a comment below. And if you find this video useful, please click the like button, subscribe to the channel, or share it with your friend and family. Last but not least, thank you so much for watching and I'll see you again. Bye bye.